Hello students, now we are going to discuss a question from electric charges and fields, and the concept is from the concept of this question is forces between multiple charges. So here in the question what they have given is a charge small q is placed at the center of the line joining two equal charges of magnitude plus q. The system of the three charges will be in equilibrium if q is equal to how much? See, options are, the first option is minus capital Q by 4, second option is plus capital Q by 4, third option is minus capital Q by 2, and fourth option is plus Q by 2. Here in this question, the value of small q can be either positive or negative also. So that value of small q is what we are supposed to calculate. And the basic information that we should be knowing here is that the net force in a system of three charges, if you are considering the net force on one of the charges or any charge, whatever the charge we consider, the net force on that particular charge out of the three charges should be equal to 0. And according to Coulomb's law, what do we know? From Coulomb's law, we have from Coulomb's law, what do we have from Coulomb's law? From Coulomb's law, we know that the force between any two charges will be equal to 1 by 4 pi epsilon naught into q1 q2 by r square. This is the force between the two charges according to the Coulomb's law. Now we are given with two charges which are of magnitude plus q. So I'll take the two charges are capital Q and capital Q are the magnitudes, and they are separated by a distance smaller. I assume the distance between the two charged particles is smaller. And now what they are doing is they are putting this charge which is q, small q. We don't know whether this is positive or negative. So they are putting this charge small q exactly at the center of the two charges. So two charges, I take one at A, the other at B, and this charge small is put at point C. Now the distance between the charges at A and C is r by 2, and the distance between the charges at C and B is r by 2. Now I consider the charge at B and I calculate the net force acting on the charge at B. So for that, the force between the charges at C and B is, I take that force as F1 and F1 here. F1 is equal to, I take it as 1 by 4 pi epsilon naught into capital Q into small q by r by 2 square, which I can write it as 1 by 4 pi epsilon naught into 4 capital Q small q divided by r square, because r by 2 whole square is r square by 4. The 4 comes to the numerator here. This is the force between the charges at C and B. Now the force between the charges at A and B is, so the distance between the charges at A and B is r. So the force, I will take it as F2 is equal to 1 by 4 pi epsilon naught into capital Q into capital Q divided by r square. So for equilibrium, net force on the charge at B should be, zero. See, I am taking the charge at B. You can even consider the charge at A and follow the same method and solve it also. You get the solution for that. So I am considering for the charge at B. So using that, what will I get here? I'll get 1 by 4 pi epsilon naught into, or else I'll just write it like this. F1 plus F2 should be equal to 0. So from there I can write it as 1 by 4 pi epsilon naught into q square divided by r square, or capital Q into small q divided by r square, 4 into capital Q into small q divided by r square, plus 1 by 4 pi epsilon naught into capital Q square by r square is equal to 0. So from which I can what I can do is I'll send 1 by 4 pi epsilon naught into 4q into small q divided by r square is equal to minus 1 by 4 pi epsilon naught into capital Q square by r square. So here 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught gets cancelled, r square gets cancelled, q square and capital Q gets cancelled here. What will I remain with is small q is equal to minus capital Q by 4. So the value of small q that is to be placed at the center of these two charges, is to be equal to how much? It should be equal to minus capital Q by 4 for the system of these three charges to be at rest. So now the correct option is the first option, which is A. Hope you understood. Please do share, subscribe and follow our channel on YouTube. Thank you.